Hannah, there you go. So this week, don't forget Thursday, Friday are long blocks, and you have early dismissal at 2 both days. And Friday flex time is just normal length, okay? Like not like longer length. So every class is just like an hour and then a break and then an hour. I don't know why they didn't just do 4 blocks, but there we are. We're doing what we're doing, so. Yeah, but the way they've done it is they have period 1 for an hour and then another hour, and then period 2 for an hour, another hour. So why not just do 1, 2, 3, 4? I don't know. It's very strange. Yeah, but we still have like anyway, we have them next week. That was not the reason that was given for it. Yes, we have 4 long blocks next week, 4 days of long blocks next week. Not Monday, but Tuesday, Wednesday, Thursday, Friday. Those ones are for the provincial assessments. Yeah, grade 10, yeah. This Thursday and Friday, so it is block 1 and 3 on Thursday, and then Friday is 2 and 4. And if you want to see the schedule, I've got it posted on my door. Okay, so if you're like, I don't know what it is, you can come to Miss Spence's door and it's right there. And I also have it right here because I don't trust myself. I need to be able to come and look at it. And I put it in the staff room, but you can't go there. So yeah. Whew. All right. So how are we doing with all of our terminology? Ish? I have a little something for you. This is not your entire vocabulary list. Okay, however, it is a large chunk of it. It just so happens that I made this for my grade 9s, so I had it on hand. It does not have solutions or saturated solutions, but it does have all your stuff about particles. So I will hand these out. 1, 2, 3, 4. 1, 2, 3, 4. Because sometimes it's nice just to be able to look at things all in one place. You know, you can cover things up. If you've got a word on one side, the definition and a picture on the other side. 1, 2, 3, 4. Okay. Oh, you already have one, that's right. I knew that. Okay, so we're going to take a look at what is happening when we recrystallize salt. Okay, this is on page, what page are we on? 111. That's easy to remember. 111. Which second video? We're going to be watching both of them. Did we watch this last day? 30-second one we did? Okay, well, we're watching it again because, like, by the time it's loaded, you know.
So here's the dish of water.
Okay, yeah, that's right, because we just sort of crammed in it at the end, and I didn't feel like it was, like, well done. That's why I don't even hardly remember it. So here's our dish of water. It's got the salt dissolved in it.
And if we look very closely, the water molecules are evaporating.
Okay, can you see the water molecules? Some of them are leaving the water. And do you see the, why is it so foggy? Let's take a look, settings. Let's just see if this helps. Is that better? Yeah, okay. It just didn't like, okay. All right, so here we go. Oh, maybe we go.
Closely, the water molecules are evaporating. And as they evaporate, the concentration of the sodium and chloride ions increases, and the charges bring them closer together, and the attractions hold them together, and they recrystallize as salt. And that's why students see those tiny salt crystals in their dish after the evaporation takes place.
So basically what's happening is the water molecules are leaving. So you have more salt or sodium ions and chloride ions closer to one another. They become more and more concentrated. And when they're closer together, they can join up and form what kind of a bond? Between sodium ion and chloride ion, you would get an ionic bond, okay? And then eventually, you know, no water will be left and you'll have crystals. So we're going to take a look then at the other video as well, which is actual like footage of salt crystals forming under a microscope. It's kind of relaxing. I don't know how educational it is, but it is kind of relaxing and just nice to see. Maybe I should take to downloading my videos ahead of time. Ha ha. Okay. This is where it gets cool. This is at 40 times magnification. 100 times. So literally all those little ions are just clicking into place like little magnets. Do we want to watch the whole 3 minutes? Okay. Okay. Maybe. I don't know. At any rate, so we're on page 111. I didn't even read it. I don't read anything that looks like an ad. It just like totally it doesn't even register with me. So when you hit, if you've got salt, when you hit 100 degrees Celsius, which is the boiling point of water, do you remember what the term IMF stands for? Intermolecular forces. What does the prefix inter mean? Between. If you go, whoa, what just happened? If you go on an international flight, you are flying in between nations, yes? When we have intermolecular forces, those are forces that are between molecules. And so what's happening down in our picture, down here, is, I'm going to show this, is going to represent an intermolecular force. Okay, so I have a little water molecule here, and I have a little water molecule here, and in between the water molecule and the water molecule, there are intermolecular forces. In between this water molecule and that water molecule, there are intermolecular forces. In between this water molecule and that water molecule, there are intermolecular forces. We could draw them all over the place. So there are intermolecular forces, firstly, between water molecules. However, there are also intermolecular forces between the water molecules and the ions. So I could say, oh, look at this little negative here. I've got an intermolecular force. In between the water and the ion. In between the water and the ion. In between the water and the ion. Yes? And I could draw them everywhere. So in between the water and the ion, in between the water and the ion, water ion, water ion, water ion, water water. Yes? Everywhere. You could draw them everywhere here. And the thing to remember about intermolecular forces, are they strong or are they weak? They are weak, okay? So IMFs are weak. So when we heat it up to 100 degrees Celsius and everything starts moving very quickly, the particles have enough energy to break the intermolecular force at the surface and go off into space. Yes? So when we heat the water, the molecules move faster, and they have enough energy, therefore the molecules have enough energy to break the IMFs and escape as a gas. And escape as individual gas molecules. So the water is turning from liquid into a gas. Is that a chemical change or is that a physical change? That is a physical change. So even though we are quote unquote undissolving the salt, it is still just a physical change. Okay, we're separating a mixture. Now, we have those weak IMFs. Man, I really need to move my pluses into the right place, don't I? And anyway, they're a little bit out of sync with where they should be. At any rate, as the water molecules go away, the ions get closer together. And we get strong ionic bonds. And we're going to show our ionic bonds like this. That's an ionic bond. Kind of like glue. Yes, in between each positive and each negative, there's the ionic bonds that hold the whole thing together. Are ionic bonds strong or weak? They're strong. So when we are evaporating the water, what kind of forces are breaking? Tell your partner, when we evaporate the water, what kind of forces are breaking? Now I'm just doing an interpretive dance, that's all. Maybe a little aerobic exercise while I'm here. Ooh, get those stretches, stretch it back and back. So what is breaking when the water is evaporating? Intermolecular forces. The water is breaking away from the other waters and from the ions. So IMFs are breaking. What's forming? Ionic bonds are forming. What's breaking? Intermolecular forces. You know that if you say it with me, you will remember it more and you will do better on a test, right? You know that, right? So if you like to just sit there and not actually say it, you're not actually engaging as many neurons as if you say it out loud. Because if you say it out loud, you get to hear your own voice as well as my voice. You get to exercise the neurons that are attached with making the sounds, right? And the more neurons for different processes that you can make connections with, the more likely it is you are to remember it. So when water is boiling, and if you can do this too, that will also help. What's breaking when the water evaporates? Intermolecular forces are breaking. What's happening when the water is boiling? Intermolecular forces are breaking. And if you do that on a test, I'll know exactly what you are thinking. You'll be like, intermolecular forces are breaking. What's happening when the water's boiling? Forces are breaking. My son and I actually use this technique to remind each other to do things when, I need to do this when I get home. He'll be like, Mom, what are you going to do when you get home? And then I'll tell him what I have to do. And then he'll say, Mom, what are you going to do when you get home? And we repeat this like 4 or 5 times. And then usually when I get home, I actually remember to do it, which is shocking because I never remember to do anything. So anyway, got a little workout there. What kind of bonds are forming? Ionic bonds. When salt water evaporates, what kind of bonds are forming? Ionic bonds. What kind of bonds? Ionic bonds. What kind of bonds form? Ionic bonds. What kind of things break? Intermolecular forces. What kind of things form? Ionic bonds. What kind of things break? Intermolecular forces. I'll have you guys doing a whole musical by the end of this. 6, 3, 1, 2, 3, 6, 9 is for the nano. Okay. So you are starting with liquid water and you're finishing with gaseous water. You are starting with aqueous sodium chloride and you're finishing with solid sodium chloride. The only thing that are changing is the states. The substances stay the same. Only their state changes. Therefore, what kind of change is this, chemical or physical? Therefore, this is a physical change. Is good? Okay. There's some questions here. We'll come back to that later. I did want to just go visit this and check in, because this is on page 97. And hopefully you have done page 97. If you have not, that's okay. You can just watch up here. Okay, I'll make it nice and big so that you can play along. Page 97, 97. I think it's 97. Yes, it is. Here I have a thing that is made of a 2 plus and a 2 minus. What is that? That is a formula unit. Here I have a carbon attached to a nitrogen, and the whole thing has a -1 charge. What is that? That is an ion. The difference between a formula unit and an ion is that the formula unit contains 2 different ions of opposite charges that balance each other out to give you the net charge equal to 0. Okay. What kind of a compound would give you a formula unit? Tell your partner, what kind of a compound? Well, what's it made of? What is this 2 plus thing over here? That's a cation. And what's the other half of this? That's an anion. And so what kind of compound do we have? We have an ionic compound. What kind of bond is between these two? That is an ionic bond. Over here, we have an ion. Is that something that can exist on its own? No, because if I had a whole bunch of like CN ions, those are cyanide ions, well, number one, cyanide is deadly, but number two, they would all repel each other because they're all negative and the whole thing would explode, okay? Now, what kind of bond do we have within the ion? We have a covalent bond, yes. How do we know that it is a covalent bond? It's non-metal, non-metal. This one looks really, really similar. What is the only thing that's different about this one compared to the one before? This one has no charge, so it is no longer an ion like this one was. And in fact, what kind of ion do we call this? This is the CN is what kind of an ion? It is an anion, and it is also a polyatomic ion. CO, what is CO? Is it an atom? No, because there's more than one atom. Is it a molecule? Yes. How do we know it is a molecule? There's no charge. And there's a nonmetal and a nonmetal. And when you have no charge and you have a nonmetal plus a nonmetal, that is a molecule. Is this an element or is this a compound? It is a compound. So it is a molecule of a compound. How do we know that it is a molecule of a compound? Yeah, there's two or more different elements. Is going through this helpful at all? Yes? Okay. Because I was like, if it's not helpful, I'll just stop right now. But I want to make sure that, you know, we're using our time wisely and I'm not just boring you. Okay. I'll give you some time to write things down if you want to. And then we're going to go to a really easy one. What's D? That's an atom. What do you notice about the charge? No charge. What do we have in our next one? How do we know that's an ion? Because it has a charge. What kind of an ion is this? Cation, because of course cats have pause. And is it a polyatomic ion? No, it is a monatomic ion, but usually we don't bother saying that. But if you wanted to, you could. You could say this is a monatomic ion. What do we have in F? That is an ionic crystal lattice. How do you know? I don't see any positive and negative ions. Describe to your partner how you can tell this is an ionic crystal lattice, even though it doesn't say positive and negative, positive, negative, positive, negative. So what are some clues that this is an ionic crystal lattice? There's negative and positive in a pattern. And they're not labeled negative and positive, but you can see they are alternating in a regular pattern, okay? So even if you don't see the positive and negative, you're like, oh, I see that pattern. What if I was to give you something like this one here? What's that? What it means is that I am not clever enough to draw a three-dimensional structure, so I'm showing it in 2 dimensions. What is it? It's a crystal lattice. Because again, it has that regular alternating pattern. What if I were to draw this? That's random, yes? So is that an ionic compound? No, what would this be? We could only describe it as a mixture. Yes, because it's random. It could be if we mix metals, metals form bonds in a different way, and they don't have to combine in set ratios. Okay, you know how sodium chloride is always 1 sodium to 1 chloride, it's never NaCl2, right? Metals, you just melt one metal, you melt the other, and then you add them in whatever proportion you want. If you want 50-50 silver and gold, you can have 50-50 silver and gold. You want 98% silver, 2% gold, you can do that. Just put in more gold and less silver, and they form these mixtures that we call alloys. Okay, so that would be the metals, but we're not going to worry about this too much for now. What is this thing here? It has a negative charge. So what is it? It's an anion, yes. What kind of an anion? Starts with a P. It is a polyatomic anion. In fact, that one's called chlorate. Okay. What's this one over here? G. What do you notice about these two? They are the same. When you see a ball and stick model, that's going to be a molecule, okay? If I asked you what type of element are those two atoms? Tell your partner what type of element are the two atoms? I just need the type, I don't need a specific atom. What type of elements? Bingo, they are nonmetals. How do you know they're nonmetals? Because you can't, like, if you have a covalent bond, they have to be nonmetals. Molecules are made of nonmetals. And if it was metals mixing, it would look more like that. Okay, that could be a mixture of metals. Here's a really weird one. J is really strange, yes? IF, what would the formula for this molecule be? IF5, which is unusual because usually iodine only forms one bond, but in this case it's forming 5. Okay, what kind of a particle is that? That is a molecule. It is also a compound, yes. What kind of a model is that? That is a ball and stick model. What do we have in K? That is a molecule. Is it a compound? All the atoms are the same, therefore it is a molecule of nonmetals. element? Could be ozone. O3, yeah? To be honest, I don't think it's ozone. Ozone is linear, but rather than being a little triangle. But we'll pretend, okay? What kind, oh, going back to J, what kind of a compound is that? Is it ionic or is it covalent? Covalent. What kind of bond do we have here, here, and here? What are your choices? What do you think? You could say, is it ionic? Is it covalent? Is it an IMF? Which one can we cross out immediately? Ionic, okay, because we know it's not made of ions, okay, because it's a molecule. Are those bonds within the molecule? Are those covalent bonds or are they IMFs? They are covalent bonds. Where would I find an intermolecular force? If I had, what would I have to have an intermolecular force? I would have to have another molecule over here. And then I could have an intermolecular force. Yes? Okay. What's that? It's an ion. What kind of ion? An anion. And it would be, is it polyatomic? Monatomic. Could you guys give me a guess as to what ion it could possibly be? That's challenging your knowledge from previous courses. It's got a -1 charge. That's okay. In our next unit, we will totally review those. It is going to be a halogen. So that's either going to be fluorine, chlorine, bromine, or iodine. Actually, fluoride, chloride, bromide, or iodide. Because remember, when we change the name, when we change to an anion, we change the name. Do we feel good with this for now? Do we want to leave it for a little? And then we can come back and maybe review a little bit next week before your test, which I would like to have on the next week. On the next week, Thursday, next week, next Thursday, test next Thursday on Unit 2. I mean, they're almost all long blocks next week. I would rather not the whole class not be the test. I don't think it's going to take you that long. November the 3rd. Okie dokie? Because we're essentially like almost done this unit at this point. That gives you a week to review, right? We will be starting our next unit before we write our test for the other one. Because we can't just review for a week, because otherwise we will not finish the course. Okay? All right. We have nap time. Do you guys want a 5-minute brain break? Yes, have a 5-minute brain break. If you want to, you may not go visit other classes, otherwise I will not be able to let you do this again, okay? You may not like go make noise. You may not walk near the office or in the commons where a administrator might come and be like, whose class are you from? Oh, you're from Miss Spence's class. Miss Spence lets her students out in the middle of class. Don't get me in trouble. Okay, yeah, you're in Mr. Satch's class. If anyone asks, okay? Don't make noise. Don't go visit your friends in other classes, but you can go to the washroom, you can get a drink, you can do some stretches, okay? And you must be back here at 1:30 because I will start teaching right at 1:30 on the dot. If you're not back, I start without you. Really? You could just do this whole thing there. Yeah. Yeah. Okay. What's up? Sorry. You need your booster. Yes. Sorry. Okay, so here we go. Here, I'll just turn this off for now. Yeah, and I wrote a little note on the back because flex time this week is short on Friday again. But what we could do is we could split the test in half, and you could do it like one half during one flex block and then the other half during another. Yeah. So what you can just come in whenever. Okay. So like either Wednesday, Thursday, or Thursday, Friday, or Wednesday, Friday, or Okay, I've listed all the choices now. So yeah, sounds good. Hi.
My own questions.
Yes.
You see my beautiful method?
Your method, I kind of get it, but on the other hand, you wrote divided by times.
I know.
You cannot do that.
Well, it's not.
No.
But look, I'll show you how it works.
No. That's not a notation that anybody uses. And what I need to do is I need you not only to be able to get the correct answer, but to be able to communicate to someone who has no idea what's going on in your brain what you have done. Do you know what I mean?
Yeah, but this is, I know it doesn't work like this in my head, but that's how it works
on the calculator. But I don't want to see what's happening on the calculator. I want to see what's happening like in a actual complete mathematical sentence.
Okay.
Yes? So this was great. This was beautiful. Just do it all like that. Okay? Yeah. Well, you've already done one or two, haven't you? Maybe you have. I don't know, you might have done some of it. So I'm just writing down things that we're just kind of wrapping up stuff now. We'll watch that one tomorrow. So for the rest of the class, we're going to be working on this stuff. If I see that people are not working on it, then we're starting our next unit. Okay? So I'd really love to give you the time to work on this. There's only 15 minutes. Just spend 15 minutes working on it. And just go back and make sure that you have done all of this, because if you're missing any of this, that's going to really hurt you, like say on a test, because you're like, I don't know, like that can be some of the confusing stuff. All right, so voila.